Hey guys, this is Dr. Aeronautics. We are blasting off for another tutorial series in Orbiter. This time we'll be doing Orbiter 2016, which is going to be just about similar to Orbiter 2010. The main reason I'm doing a new tutorial series is not really because of the new version, but because now that I watch over my older series, I find that it's less of a press this key, you need to execute this maneuver between this window and this window, and it's kind of more of a watch me do this kind of thing, which really doesn't, it's not a good tutorial series. So I'm making the 2016 ones, and I'm going to be using the lessons learned from the previous oh dear. I've never seen this message before. Well, let's go ahead and ignore it for now. So yeah, that's basically the idea, is to use the lessons learned from the Orbiter 2010 version to make a much better Orbiter 2016 version. So, let me dismiss this pop-up, and then we'll keep moving. Okay, now that I got that squared away, how do I get and spacecraft on my computer? For those who are curious, this is the BNSF Highline Bridge over the Two Medicine River near Glacier Park, Montana. Step 1, connect to the internet. Step 2, you're going to open the browser and you're going to go to, it's like Orbiter. What happened to my cursor? Let's try that again. Orbiter. And it's going to be something like medphys.co.uk or something. Okay, now I could have just gotten the URL beforehand, but just so you guys understand what comes up, I'm going to actually just go through it. So here's the first thing that I get. And this looks right. So if we go to home, this is the Orbiter Spaceflight Simulator homepage. This is where you can get this thing for completely free. It's quite a bit more popular than I would think. It's actually got 8.5 million views, which is good. One of the bonuses that we're going to have in doing 2016 is now there's terrain elevation maps. They're not too accurate. Mainly what they do is just create bumps for mountains. You can make it as accurate as you want, but I think the default, what comes with the simulator, is kind of unrealistic. I mean, there's mountains where there's supposed to be mountains, but if you're expecting to see, like, let's say that you live under the front range, right, and so you're used to what your mountain range looks like, you probably won't get this that you'll get in Flight Simulator, but you can do it. So you click the download page, and you get the core package, which is what you want. You go to one of the download mirrors, and I usually do the HTTP zip installer. Again, that's for advanced users. If you just want to run it from a program, like from your program files x86 folder, then that works. But is this thing still running? Yes, it is. Okay, just disappeared. Okay, so basically, I'm not going to download it because I have already downloaded it. I think the reason they want you to do a torrent is because you can use this MD5 checksum, but I usually don't do it. So when you download it, at least when I downloaded 2010, you get Orbiter with 6 digits on it, and that will tell you what you have. So let's go ahead and open it up. You get a zip file. And basically what you do is you extract that, so right-click and extract. If you don't know that, you're not going to be able to fly Space Simulator. Okay, so this is what you're going to get if you open up the folder that you zip to. Some of the things here aren't in there by default, but that's okay. So now what you want to do is double-click this Orbiter application. Sometimes you have it sent to your desktop, but you can open the extracted folder that you get here. Okay, so now that I've double-clicked it, you get this Launchpad, and this is where you set up your simulator. So, this has been done before. So this is the previous simulator that I've done, or the previous simulation I've done. So now you can come into parameters and check what you want and don't want. I like to make it as realistic as possible. So if you want to do that, you check these three and leave the auto refuel on pad open. And then check all the perturbations. The atmospheric wind effects can be a little bit unrealistic because your craft is extremely heavy. And then you can map the stars and all sorts of other things here. You can add a celestial sphere, which makes the stars look colorful. Transects won't come down by default. One thing I highly recommend getting is Orbiter sound, and I think that's from Dan's stuff. If you go to, I think it's just Orbiter Sound 4.0. And it should come up pretty quick. Yep, here you go. So what we want is download, and you just install that. Basically, I think it comes with an installer, and when you get it, you get an installer package, and then you get the sound config file, which you want to do because every computer is different. Then you can configure your sound. Okay, sometimes it's useful to select scenario editor. I highly recommend it. These are optional. I just do them for performance reasons. The external MFD I'll have to explain later. And yeah, if you download Orbiter sound, check that, because if you don't have sound, it really sucks. Orbiter is compatible with a joystick, so you can do that. And you can go through some of the other options as well. But as long as you really download it and download the sound, you should be good. Okay, so I'm not going to do this, but there is a welcome, and it's a scenario. So if I launch this, when you first open Orbiter, you probably want to launch it to figure out, what you can do in this thing. And basically, it's a playback. So you just sit back, you don't do anything, and you watch things as they happen. This is really to kind of understand exactly what you can do with the system. And some of these are just fun. Like, for example, here's the Alps. Maybe that is somewhat slightly realistic, because those do have the drainage channels for the glaciers in the Alps. So I don't know. Maybe that is better than I thought. So anyway, you can do that. But for this one, I'm going to start my tutorials, and I always prefer the DGS ready for takeoff. So we're going to go ahead and double-click this, and then it will start loading us into the simulator. Okay, so here we are. This is somewhere at Kennedy Space Center. I guess it's looks like 30. I can't read the runway. It's too dirty. So the mouse works in the simulator. So to pan around, you right-click, and then you drag. So I guess it's down is up is down, and then you can go from left to right as well. So just
on the LDR card, step 4. Just checking for sync config. Copy.
Okay, that's going to get old real fast, so let me fix that. Okay, so I had to exit. If you have to exit at any time, eventually this menu at the top here will time out. But basically, I had to turn off ATC. The Orbiter sound has a feature will randomly play astronaut sounds every so often from real NASA missions, and that's kind of nice, but it gets old real fast when you're not. It's like, they'll say hatch is closed and latched, and from my experience, you just don't want to pay attention to that stuff, because that's not the focus of the mission right now. The focus of the mission is the tutorial. Why hasn't this thing timed out yet? The F4 button. Okay, so F4, this is a learning experience for me because I don't use 2016 all the time. And now that I think about it, we won't be able to use 2016 when I start going through some of the add-ons, which are which add so much functionality to Orbiter, but aren't yet built for 2016. So we'll have to probably go to 2010 for that. But anyway, F4 will toggle this menu open and closed. All you got to do is just press that exit button, and then you'll exit. Alternatively, you can Alt F4, but that's kind of like a hard kill. It's easier to soft kill. Okay, so like I was going to say earlier, yeah, this is KSC. So I don't know which one is 39A and which one is 39B, but these are the pads that were originally used for the Space Shuttle and the Saturn V, and now SpaceX is using it. So out here, obviously, is the huge vehicle assembly building, modeled as it appears in real life, as well as basically the entire center. Like, you know, if you have a desk job, you're going to be in this office park somewhere. And then there's this long taxiway which goes up to this hangar, which I really like, and out onto the runway. Okay, so this you zoom in and out using the mouse wheel, by the way. I think you can also what is it? Page up and yeah, page up. So page up will zoom out. Page down will zoom in. You can't use the arrow keys though. Okay. So this is our craft. This is known as the Deltaglider. It comes default with Orbiter. If you download Orbiter, you don't even need the sound, but I mean the sound is really nice to have. This is a completely default craft, and basically what it is it's a space plane. If you've heard of an SSTO stands for Single Stage to Orbit, which basically means this space plane has the capability of taking off the runway, going straight up into space, accelerating to orbital velocity, shutting down its engines, and then orbiting the Earth for, well, there's no life support system simulated, so you can basically orbit the Earth until drag pulls you back down. And then you can just keep burning again to raise your orbit, which I'll explain later how to do. And that will basically keep you up longer. So if you're not a fan of realism, here you go. You know, your space plane from, I don't know, 3000, the year 3000. Nothing like what we can do now. If you're looking for more realism, highly suggest the XR2 Raven Star, which I'll eventually get to later on, or the Deltaglider 4. Much, much more realistic, something that we could probably do in 100 or 200 years. But this is basically a plug and fly. And it can hold about 5 people and enough fuel to, I think it has just enough fuel to reach the moon and potentially come back. I know it can reach the moon. Not 100% sure if it has enough to come back. But if you select auto refuel on pad, then when you land, you can fill up again. But again, it's not realistic because it's an instant fill up. XR2 Raven Star will allow you to slowly fill. The Deltaglider 4 will actually allow you to pull a truck up. Okay, so real quick, we'll go through the menu. If I press the ship button, it allows you to select different ships. So right now, I think this is the GL01S. If I want to select another ship, I press it. So let's see what GL02 is. I press it, and you press the apply, and now it will change the function. So when I move my joystick, I don't think it's working now. There we go. When I move my joystick, I'm controlling this craft. But if I go to GL02 and click apply, now we're on Mars. And now I start moving this thing. Ooh, someone forgot to turn the RCS system off. You can see I'm now controlling this craft here on Mars. And we want the GL01S. And when you're done with this, you can just click close. This camera will allow you to change camera, so you can, you know, it's just the manual version of what I did with the keyboard. You can target spaceports like, why the heck do I have this in here? That's not real. I don't know. We were talking about the front range. Actually, we were talking about my desktop. So let's bring up Glacier Park International. Apply. So now this is Glacier Park, Montana. Not exactly. Oh, this is. I think this is near Kalispell. Yeah. Let's see if we can. You know what? Maybe this thing. I think this thing does actually have good mountains because I'm starting to see some things here. Some things with. This is the camera, by the way. It's just zoomed incredibly far out. Let's find east and go out. Basically, what I'm trying to do is assess how well the terrain is modeled. I haven't been in 2016 a lot. Okay, well, I can't tell if that's the Front Range, but point is, we're in the middle of the Rocky Mountains. So there you go, mountains. So you can target spaceports. So this is qualified as a spaceport. Now, keep in mind, I have an add-on called the Civilian Airports. So if you don't, yeah, there we go. Down in Cuba. This is a default spaceport. You'll get it with the default download. What is that thing? What the heck? That looks like a tram, except it's on the ground. The trams are supposed to be on this thing. This thing here is a sky tram. Huh. It's not here. It's mispositioned. That sucks. Another reason why I'm complaining about 2016. And there's another spaceship here, and all right, that's the point. You can also target astronomical bodies too. Like I got a lot of add-ons. So let's take a look at an asteroid Pallas. Apply. Where the heck are we? Okay, we were just over-zoomed on the night side. So this is an extremely large asteroid. If I zoom out, you should be able to see, that might be Earth. Not 100% sure. Actually, you know what? That's probably Neptune because we're looking far out from the sun. This is kind of like an improvised astronomy feature that you can do. That's definitely Venus. That's obviously the sun. And if we can find Earth and Moon, it's usually a blue and gray pair. That's the cool thing about the Earth and the Moon is when you come very far away from them, you can see the Moon as well as the Earth, and it looks like a double planet. One of them is big and blue, the other is tiny and gray. But it doesn't look like I can find it right now. So let's keep moving through here. You can change the tracking, which I'm not going to go into. That's a little bit more advanced. Same with this stuff. Mess around with it when you can. Field of view. This is important. This has to do with how big the objects appear on your screen, right? So what you want to do, if you're looking for the ultimate realism, is figure out how big the sun appears from the Earth. There is beautiful Earth. Isn't that fantastic? So figure out how big the sun appears for you in real life, which is, for most people, that's about half a pinky, which is 30 arc minutes, half a degree. And what you want to do as a quick check is you want to hold your pinky out, if you're human and have one, and you basically want to adjust it so that the sun appears exactly as large as the sun would appear in real life. And for me, it looks like that's about 50 degrees, maybe a little bit smaller, like 55 maybe. Yeah, I'll think it's 55. For ultimate realism, although I highly do not suggest doing this, you can look at the sun and look at it for a good 5 seconds so it gets burned into your corneas, and then come and look at Orbiter, blink your eyes a couple times so that you can see the sun's image burned into your cornea, and then adjust the screen, and then wait a day for your vision to come back. Yeah, so don't do that. Okay, this third thing, speed. You can time warp in Orbiter. You can also use the T and R keys to time warp. So if I do T, you'll see up here in the corner that's 10x, and notice the time acceleration. If I press R, now that goes down by 10. You can even do it negative to 0.1. I think that's the minimum you can go to. That's if you want to watch like a slow collision or something. But collisions aren't really modeled very well. If you want to pause the simulator, Control P will do it. And you'll get the pause symbol up there, and then you'll get a run when you run it. You can also press this pause button up here. And then press the play button. Okay, so this info will give you information on various things. So you can do vessels like our spacecraft. You can do camera target. This will give you information about the Earth itself, its mass, its radius, its gravitational moments, specifically the one simulated. This is important if you're going to do an orbit plot. I've taken advanced orbital mechanics and computational dynamics and dynamics and control. So I know how to factor in this J2, J3, J4, J5 covariance matrices and get a really accurate orbit. It's long, it's boring, and it involves lots of math, but it's there if you want it. Here's the day length in seconds. Notice that this is the sidereal day, which means it's the time for the entire Earth to make a full 360-degree rotation, not the time that it takes to go from local noon till local noon again, because by the time the Earth rotates once, the Earth will move a good distance along its orbit, and the sun will now appear over here. So it's a little bit longer. Anyway, yeah, knock yourself out with this stuff. So we can even find information about our craft, GL01S. So the mass is 26,700 kilograms, roughly. This is the dry mass is the emptiness, and the propellant mass is how much propellant is loaded on board. These two numbers are very, very important if you want to do. Actually, it doesn't matter for the Deltaglider, and I'll explain why in a minute. But if you want to do it with the other crafts that don't solve the equation for you, very useful. Here's our engine powers. It's current right now. These orbital frame. This doesn't matter because we're landed. What matters now is the surface relative parameters. These won't change. This is where we're landed on the Earth. Our altitude is not 0 because it's using the craft center of mass. Oh dear. This is the temperature of the environment outside and the density. If I were in space, it'd be a lot lower. And yeah, all our aerodynamic parameters if you're interested. You can do bases, and if you want to go to choose a celestial body, you can go here. To navigate, what you do is you go up, and then you can choose what you want. Wow, I didn't know I had Sedna loaded into this. Nice, we're going to have some fun. So yeah, information about the sun itself. Here you go. For now, I'm going to go back to the focus vessel, which is us. So when I put the camera back, it'll go to that one as well. Let's see, function. This is if you have the scenario editor up, you can open that. I might do an actual info tutorial on how this works, but basically you can create and destroy crafts as you please. It's not deleting, it's or not destroying, it's deleting them. It's a harmless delete, like just disappears. Okay, so this is why I wanted to go into space, right? You wanted to figure out what. Let's see if we can find that blue planet out again. So we need to find Venus, which is a big yellow dot. Oh, don't tell me I can't find Venus. Wow, I cannot find Venus. So in order to not waste any more time, we'll go through this. So in planetarium, you have visual helpers. So if I do planetarium mode, check. Here it is. I forgot the Earth is inclined 23.5 degrees. So I have it set to the Earth's equator right now. And as you can see here, here's the ecliptic, which is where you're going to find the planets. And I was looking on this line, which is the celestial equator. So here's all the planets selected for you so that you can see them. And if I have celestial grid selected, so basically here's what you need to know. Here's the equator, celestial North Pole, celestial South Pole. That's basically all you need to know. And these are even demarcations. I think it's like 15 degrees. 6. Yeah, that's 15 degrees. Now, if I do ecliptic grid, it will also do... The ecliptic is the Earth's orbital plane around the sun. Basically, if you were to draw a line from the Earth where it is now to a line where the Earth would be in any other part of its orbit, it would appear in what's called the orbital plane. I don't find the ecliptic grid very useful. All I want to know is where the ecliptic line is. Now, if I do target equator, it'll now highlight the equator of the Earth here as this color. You can also turn the constellations on and off. If you want, you can do short, and then once you know how to name them, you can do this. And then once you know how to do that, you can do that. And then you won't need this anymore for full realism. You can show vessels and surface bases. So if we want to show Cape Canaveral, actually let's do Havana. I have to go in pretty far for this to work. Let's see if this comes up. My geography is a little bit off. There it is. And there it is. Ambient sound effects simulated. Here's some of the other places that I have dotted. Oh, wow. These display a lot further out than they used to in Orbiter 2010. So I highly recommend the civilian airports, because then you can fly to a whole bunch of different places around the world. Okay. Let's turn that off. You can do VOR transmitters, and then they have VOR equipment around here like that you would use to fly at in real life, like VOR transmitters. Like let's go up to somewhere big like New York that would have them. Where am I? Okay, New York is currently enduring a nor'easter, so let's try not to mess around there. San Fran, can we go to San Fran? Yes, we can. Okay, here's SFO. And SFO has its VOR transmitters here, which are used for navigation for aircraft. Okay, turn that off. Now if I do celestial, check it out. Now you can see the star names. And these are important to learn your stars. So here's all the star names in Orion. Now if I do surface, you might take a frame rate hit, depending on how beefy your PC is. And you can see there's all sorts of things here. Cities, surface features. And they have these for other planets too, including the moon. Various islands. Look at that, that's Chicxulub. Various impact craters that exist. Not so important on the Earth, but important on other planets. Islands, pretty cool. You know, you can see Tuvalu. I think Tonga is somewhere down here. I think Rapa. I think that's Easter Island. Does not look like it's resolute enough to show Rapa Nui, which is Easter Island. Somewhere down here is Tonga. I can't find it now. It helps when you're lower to the Earth and in a low orbit. But yeah, turn that off because that will consume your... Now if you do bodies, then it'll show the Earth. So there we go. Now if I show body force vectors, this will draw it around the craft. So let's go to ship. Actually, we don't want that. We want camera, target, vessels, GL01S, apply, close. Now if I do body force vectors, it will basically draw the 4 fundamental forces of flight: lift, weight, thrust, drag. There are none here, so it's not gonna... well, we should have weight. Huh. I don't know why it's not displaying, but when we get going, that's when it really matters. And then you can display coordinate axes. This is mainly for debug purposes. So the vessel orientations. If you want to do attitude control, this is extremely important. I do that stuff in real life, and the vessel coordinate axes are everything. You can also do the negative axes, but that's redundant. All right, let's turn planetarium mode off. Let's go to map, and this is a new feature of 2016. So you can choose anything. Like here's Mars. These lines here represent the datum, which is basically sea level. I can't tell you what's above the datum and what's below it, but they're marked off. I don't know how Find Vessel works. Yeah, I don't know how this stuff works. This is a new feature to me. So you can play around with that. Okay, record. This is a bit meta right now, but if I do record, then you can actually record a video and then watch it later in the simulator, and your effects won't affect anything. So there's information here. You can edit it later on. That's how the tutorial video that I was showing you earlier did it. And you have a help menu. It is reasonably helpful, so I do recommend reading into this if you're kind of lost. And then if you do save, it'll create a quick save. I think that's how that works. It's change and exits. Okay, so here's the fun part, right? Press F1. Now we're inside the craft. And I used to remember this thing being blue. It's red. Okay, so when you first load it up, you're in the 3D cockpit mode. So if you have a joystick hat switch, you can use the hat switch. Otherwise, right-click and you move it around. And now you can see we're an astronaut, and here are our astronauts. This is our control panel. We can not... Oh, we can! How about that? This thing actually functions. We can actually control the craft from this. This is a new feature, and I actually kind of like that. This... Oh, nice. I love that. What did I... Oh, that's... Okay. I was about to say, it's supposed to make the funny noise.
Rotation.
Yeah, there we go.
Attitude off.
Fun stuff. I know what I'm doing here. There's some buttons you don't want to press. Okay, so for the majority of this tutorial, I'm going to be in a different mode. So let's go ahead and press F8. This is the glass cockpit mode. Every vessel in Orbiter will have a glass mode. Not everyone will have a 3D mode. Not everyone will have a 2D mode. But everyone will have a glass mode. So that's important. And that brings us to the first topic of the tutorial, multifunctional displays, or MFDs. This is a multifunctional display. This is another multifunctional display. They're interactive. So, to access a multifunctional display, you press this select button with your mouse. There's also keyboard shortcuts, I think. I don't remember what they are, though. And then you can choose the various ones. So here are all your options. Orbit, surface map, blah, 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 blah. Press it again, and if there's a second page, it will display. I don't have 2 pages worth of menus, so it will only display once. So let's go ahead and go to surface. That's an important thing we want. This is very similar to a primary flight display in an aircraft. And you also have the HSI, the horizontal situation indicator, and this is very similar to the nav equipment in most aircraft. We can actually use it to dial in to frequencies, but I won't mess around with that just yet. Up here is not really part of a multifunctional display. If I go to menu, This is a new thing. Okay, I think what the menu, yeah, the menu button will essentially tell you what the information, or rather what every single button does. So for example, this is IAS, that's indicated airspeed. Now I could do tasks, but you might not know that that's true airspeed. I do menu, and you can see it's true airspeed. Indicate is important for flying as an aircraft. True is important for debug purposes. Ground speed is important when you're taxiing, or if you want to know what your GPS speed is. And OS is your orbital speed. That's only for orbits. As you can see, it says that we're moving. And we are. We're moving on a planet that's constantly revolving at, what did they say, 900 miles an hour? Although it depends on where you are based on a cosine relationship north or south of the equator. I think I filled my nerd quota for today. Okay. I press F8 again. Now this is where I'm going to be conducting most of my tutorial from. This is the 2D cockpit display. This is fully responsive, just like the 3D, and whatever doesn't work in the 3D will work in the 2D. Guaranteed. You can control down arrow and control up arrow, and that will display more things. So, yep. We have various things here. So, let's start easy with the top panel. These are new to me, actually. So to hide this menu, press F4. Now it's gone. I'm gonna have to learn how to do this. This is a lot more functionality than I've had before. But anyway, to work a switch, you basically click open or close. I don't know what these things do, to be honest. Maybe it's for the airlock, but as long as the cabin stays pressurized, we're okay. I think the external hatch is going to be the atmospheric pressure. The airlock is whatever's inside the airlock, and I'll show you guys that in a minute. And then you have the external lock, and I guess that's what's outside. Yeah, that's whatever is outside the external airlock. So, believe it or not, there are instances where your airlock has a different pressure than your hatch. Because, for example, your top hatch is right here. So to open that top hatch, press the arrow here. And there we go. So the hatch has opened. Now, there is a condition where it might be different because your docking adapter's here. So if we fly to the International Space Station, we'll dock right here. And then when they pressurize the middle, then it will become atmospheric. But not this section, because this section does not hook up. So it's important to show both of that. Okay, so let's go ahead, and we can't work these buttons yet because we need to open the nose cone first. Here are our lights, so let's go ahead and turn off the strobe, or turn on the strobe beacon and navigation. I think the dock lights will essentially create a spotlight straight forward, and then if whatever, I'll close that. If I go to land, then I guess our landing lights would appear, but although I'm not seeing any change. Whatever. These don't have any functionality other than for, ooh, look at me. There's a radiator here, and that's used to cool the systems. It's not simulated, so if you don't deploy it, there's no consequences. But if you fly the XR2 Raven Star, there will be consequences. Okay. So this stuff up here is scramjet temperature information. That's for flying. I'll give you a scramjet demo later. Okay. So now I am down here. The next thing I will start off with is the heads-up display, or the HUD. So that's what you see here. The surface Earth, TAS, R, ladder, 20 plus 10. All of this, and all of this is the heads-up display. So maybe I should demonstrate that by turning it off. And I forget how to turn it off. Okay. Well, this is most interesting. Let's try Control H. I can't believe that. Yes, it's Control H. So, no HUD. Uh-oh. Oh, now it's gone. That's not good. Okay. And I pressed surf to bring it back. So there are 3 modes of HUD that you can do by default. Dock, which is useful when you're docking. It shows your target, essentially, based on radio. Surface, which is good for flying around. Most fighter jets will have something like this. And orbit, which is useful really on orbit. So let's go ahead and explain the surface. So this big thing in the middle here is your pitch ladder. This is marked off in 10 degrees pitch. This is your horizon line. So this is plus 10 degrees pitch, plus 20 degrees, minus 10, minus 20 degrees. And that'll go 360 degrees. You don't have to worry about gimbal lock or anything complicated like that. Unfortunately, there is no roll indicator other than what you have here. These are marked off at 45-degree angles. So if you line this up with a line on your pitch ladder, then that's a 45-degree bank. These 3 boxes here represent your landing gear being down. These 2 bars will always move. They represent your wings. They will always move with this piece here. And I forgot what I was going to do earlier. So I press F8 again and again and again to get here. Now, if you press Alt-H, you can actually change the color of this thing. I find green very useful for space. I find blue very useful for Mars. Green is also very useful for the moon. However, on the Earth, I prefer orange-red because look at that. It very nicely shows up against a cyan atmosphere. If I did blue, well, they can also do yellow. I think I've used yellow for some of the ice giants in Saturn. Otherwise, I don't find much use for it. Don't use yellow at Venus. Yeah, and blue is just don't use blue and green. Unless you are like being challenged with seeing it. Now this bar up here is the it's your yaw tape. So right now we're at 330 degrees, which means this is runway 33. As we yaw around, you'll see this move. This title here is what we're looking at. So right now it's showing surface Earth. If I were on another planet or moon, I could do that. The other thing too is you could do orbit, and now it's saying orbit Earth. So this is the Earth and set to orbit. So let's do something else. Let's do select and orbit, and this is the most useful MFD once you've shut your engines down at main engine cutoff. Now if I do ref, it will allow us to pick an object. So let's go to the Kuiper Belt object Orcus. Press enter. This is what our orbit looks like relative to Orcus. It's a complete mess, and yes, it's completely irrelevant to what's going on now. Even if I were going to Orcus, it would not become relevant until we get about 6 months from Orcus, which in the grand scheme of things, it will take about 30 years to get there. So, yeah, about 96% of the way through it will be completely useless. Let's do HUD. There you go, orbit Orcus. So this is what it looks like. We're at 80 degrees yaw, we're at 80 degrees pitch. That's almost all there is to say to it. So here, this thing that says rad, and this thing here that says OS. So the OS stands for orbital speed. This, when it says K, is in kilometers per second. So what this is saying is, relative to Orcus, we are going 34.29 kilometers per second. Now let's look over here. This is rad, or radial distance. In other words, distance from the center, the geographic center of the object. For the Earth, draw a line from the North Pole to the South Pole, and then draw a line from 0 longitude on the equator to the international date line 180 longitude on the equator, and where those two lines intersect at the very geographical center of the Earth is the reference of where this is being said. So from the center of Orcus, we are 5.083 terameters, or 5.083 times 10 to the 12th meters from the center of Orcus. Basically, that translates as a long way away. If I do AR, that will auto-reference to the strongest gravitational object. This G basically says that Orcus is providing 0.00%, or actually this is out of 1. So this is 0.00% of the gravity is being provided by Orcus. Not a surprise, because it's a tiny rock far, far away. Do autoreference. Yeah, the Earth provides just about 100% of the gravity. But if you're curious, there are some other things involving gravity. Let's go to Vocus Vessel and see what else is... this should be... Okay. We're landed, so it's not showing up. But if we weren't landed, it would show us that the Sun, the Moon, as well as Jupiter is actually tugging quite a bit on the craft. But it's noise, at least right now, so we don't have to worry about it. And do the same thing again. Do HUD, copy to HUD, HUD, and now this is the orbital information. 407.9, nothing meters per second. So to go from meters per second, this simulator uses meters per second in kilometers. So before I translate, here is the radial distance, 6.371 megameters, or 6.371 times 10 to the 6 meters from the center of the Earth, which is basically looking straight down into the Earth. The center of the core. That's how far away we are. Go select surface and HUD, and here's the ground information. True airspeed 0.00 meters per second, which means stopped. Radius, I think that's what that meant to say, 2.46 nothing meters. Altitude. So basically what that means is distance above the ground. We're 2.46 meters above the ground, and you can see because we're on landing gear struts, yeah, that looks about right. Back inside. What else can we do? Okay, so meters per second and kilometers per second. 1 kilometer per second is 1,000 meters per second. To go from 1 meter per second to 1 mile per hour, you multiply meters per second by 2.2369 to take miles per hour and get meters per second, divide miles per hour by 2.2369, and you'll get it. To convert your altitude to feet, multiply meters by 3.28, and to go from feet to meters, divide by 3.28. To go from meters per second to to go from meters per second to kilometers per hour, multiply by 3.6. To go from kilometers per hour to meters per second, divide by 3.6. There, done. don't have to convert this anymore. Now, I will, if it's available in some add-ons, which it is, switch to feet and knots below 100,000 feet. Once I hit 100,000 feet, I am all metric, including temperature. Okay. So that's just about it for the HUD. So let me tell you about the screen, the stuff that's not part of the actual inside of the simulation, the fourth wall material. Target. So this is the target of the camera, the GL-01S spacecraft. The camera is in a track mode with the relative position. The field of view is 55 degrees and the distance is 130 meters. Oh, now it's 95.10 meters. Ooh, now it's 850.1 meters. Get the idea? Good. Here's your date, Wednesday, March 14th at 4 p.m., 4:46:02 p.m., the year 2001. This is UTC Universal Time. This is the time of basically Great Britain, Zulu, GMT, Greenwich Mean Time. There we go. Right, because local, it's about local noon, right? Yeah, it's. I think it's just local noon right now. So it's 4 p.m., so we'd expect it to be close to evening, right? So what's close to evening right now? Great Britain, because it's like 4 something p.m. Whoa, what the heck is this? Oh, the Arctic Ocean actually still has ice in it. Well, that's good. Oh, it was 2001. Where the heck is Great Britain? Let's cheat. F9. I don't have Surface on. Perfect. Okay, well, it's probably somewhere down here. It's obscured because of the amount of cloud cover right now. Ow, my eyes. Okay, not important right now. Alright, so this MJD is the modified Julian date. And this is from an epoch that was in I think it's the late 1800s. So what we can do is figure out 51,982, and then we'll divide by the amount of days in a year, and we get 142 years, and it's 2001. So this is the number of days since some time in July of the year 1858. This is useful for figuring out the amount of days of transit between one given point and another. And the sim, that's the amount of time that your simulation has ticked, not been up. For example, if I time accelerate, you will now notice it now goes 10 times faster. Press R, and we're back to normal. Alright, so let's go over the craft. So guess what these two things are? These are the actual multifunctional displays built into the craft 2D panel. So this is how they would actually appear in real life. You can power them on and off as you want. For distractions, I'm going to hide them from now. Or now. This is your primary flight display. Doesn't really do any... Well, it does... I mean, it works. And it actually, you know what? It's really useful for banking because their HUD doesn't have a bank. But, yeah, your bank and your pitch and your yaw is marked off here. Okay. This is your angle of attack indicator. This indicates how close the front of the nose is with the airstream. A high angle of attack can be dangerous. It can cause spins, and it can cause excessive heating. It can cause stresses. It can be bad, but it's not always bad. When you re-enter, you want a high angle of attack because it slows you down. When it's low, it means you're good, fuel-efficient flying. Otherwise, if it's too high, you're not flying, you're falling. This is your vertical speed indicator. It doesn't differ from that used in an aircraft, except instead of feet per second, we're using meters per second. To convert between feet per second and meters per second, multiply by 3.28. Or divide by that. Okay, this is your air flight control surfaces mode. Right now I don't have anyone selected, which means if I go outside, even though I have control of this craft, if I start moving my joystick around, you won't see anything moving. If I set it to pitch, you will be able to see the elevator moves, but you won't see the ailerons moving, and you won't see the rudders. If I do on, now we can move everything. So there's the, I think it's called ailerons because it's both, right? So there's your elevators and there's your rudder. So real quick, for those of you that don't know the dynamics of flight, this is kind of important. Your elevators up and down, they control the airplane's pitch. The pitch is, this in the cockpit, your pitch is, if you're going up or you're going down. It's basically, how high you are relative to the horizon. Next is your ailerons. Normally they're called ailerons because they're separate from your rudders, but they're called ailerons because guess what? The same material which is used for the elevators is used for the rudders. It's just one goes down. Your ailerons will control your bank. So that's, how much you're tilted to either side. And lastly is your rudders, which are right here, and they control the direction of steering. So whether you're pointing this way or this way, this kind of movement, this is yaw. Enough said. Here's your RCS modes. The air flight control surfaces need air, right? If you're smart, then you'd be saying earlier, hey, you can't use those. I can in an atmosphere, but I can't in space. And the simulator will show that. If I don't turn the RCS on, I will lose control of the craft. So you have to use what's called a reaction control system.
Rotation.
Now rotation will fire rotational jets. Now if I zoom in, you'll see these tiny little holes. These tiny little holes on the side of the craft. These are small jets that will fire, and these jets will allow, they're like small rockets. The plume goes one way, the craft goes the other way, and if it's mounted off of the center of gravity, which it is, you'll get a rotation. Translation. So now what happens if I fire this one and this one at the exact same time? Well, both are firing outward from the center of gravity. Both are offset from the center of gravity by the same amount. So if you draw a longitudinal line right here, the amount cancels, and it's the effect of having a single rocket at front or behind you, which means translation means you scoot forward or backwards, or you scoot side to side, or you scoot up to down based on whatever is being done. So when you drift in a car, a drift is considered a translative maneuver. When you accelerate and you brake, that's considered a translative maneuver. When you turn your car on an exit ramp, that's a rotational maneuver. When you go up a bridge, that's a rotational maneuver. When you fall off a bridge, that's a translational maneuver.
Rotation.
Attitude off.
So we're going to turn that off so that I don't fire the jets. That's what you don't want fired. You can program the RCS, and these are your information here. So you can run these autopilots. I'm not going to explain how they work, but the most important one is kill rotation. If you're spinning, and there's no airstream obviously in space to stop your rotation, so the kill rotation is an autopilot which will null your rates. It will stop your rotation so that you're not moving fixed to some object. Here are your angular rates. So basically, if you've got rates, which will be shown green, yellow, or red on these ticker tapes, positive or negative. This is angular velocity for roll, pitch, and yaw in degrees per second, angular acceleration. And the acceleration will be caused by atmosphere or the air flight control surfaces or the RCS jets while they're firing. And the torque, the amount of force on the twisting force on the aircraft. So yeah, kill rotation will basically stop them all. Okay, this is your autopilot. This is going to be marked off in, what is this? This is going to be meters. This is going to be meters per second. And this is going to be your heading. So let's say we went to a normal altitude, a normal airliner cruises at 12 kilometers, 220 meters per second. And let's say we're going to go west, right? So 12 kilometers, that's 12,000. This is like a real autopilot. It will eventually compound its numbers so that you don't have to hold down forever. So I'm going to release it at 10, because if I don't, then it will 12. Perfect. You get the idea. The 10, 20, and we'll go up to 220. Oh, too far. And okay. Done. Heading 270. Now, if I did course, we could follow a VOR beacon, which I'll explain how to do later. And you press this button to activate it. I'm not going to press it now because then we'll just fire away and start rolling across the ground. All right, so what I just did is I held down the down arrow. You can do down or up arrow. So we've got some more things here. We've got an elevator trim, and your trim will reduce the amount of pressure that you have to hold on the stick. Notice this flapper, this elevator has come up a little bit. So basically, if I'm ascending for several minutes, I don't need to hold it down. I can just set this thing and forget about it. That way my wrist doesn't get tired. The air brake, I can deploy the air brake, and basically these things open.
Lad. Inner door open.
Interesting. So here you go. That's the air brake. And as you might expect, we can still fly with it open. This is pretty similar to the air brake on the F-104 Starfighter. A lot of this stuff it comes from the F-104 Starfighter and the SR-71 Blackbird, because those things are so freaking fast. That seems like an error. There should be no ladder extending. Okay, these are the thrusters, right? When you want to fire the rocket, this is the big lever that you use. You slide that forward, click and drag. What is it? Alt plus and minus? Control plus and minus. Yeah, it's Control plus and minus. You can press plus or minus real quick if you want to, for instantaneous full or zero. This is your hover, so that's number pad 0 and number pad period, or full stop, depending on where you're from. And these are your scramjets. So if you're moving, I can actually do this now. That's Alt plus and minus, your scramjets. Why am I not worried about doing this? Because scramjets are completely ineffective when you're still. These little guys under here, they are the scramjets. Scramjets actually use a type of very high potent but also hard to ignite fuel. The only, I think the only scramjet that exists is like the X-43 and other DARPA stuff that we don't know about. Scramjets are insanely advanced. Even the SR-71 is considered a ramjet, which is not the same as a scramjet. So what is a scramjet? Basically, you have some fuel on board, and you scramble some oxygen into this chamber. because of how fast you're going, the air compresses itself down here. You throw the mixture in, the mixture of gas in, and it automatically ignites because it's already compressed, and it just comes right out the back. And you get thrust run. Our main fuel is somewhere up in this chamber here, and it comes out here. It's got oxidizer as well. So scramjets only work in an atmosphere, only in a thin atmosphere. Rockets can work anywhere where the atmospheric pressure is lower than the chamber pressure. We have gimbals. So if I do auto gimbal, then if we're moving, I don't think it does it when we're stopped, then you can actually gimbal the main engines. So let's see, put it to manual. And there we go. I'm gonna gimbal the left engine so that you can see it's different than the right engine. Wow. I'm not gonna say it's not gimbaled, but it's kind of hard to tell. Set it back to auto. That'll center. Oh, I know what to do. Let's pitch down and set it back to auto. See what happens. Yeah, I saw it. I saw it move a little bit. Okay. You can do the same with the hover engines. This is kind of new. Here's some hover autopilots. If you do hover hold, then you'll basically hover like as if you defy gravity, essentially, neither up nor down. You can also set an altitude to hold at, which is kind of handy. You can also set a vertical speed that you can use this to land and such. This is a backup for your horizontal situation indicator. You also have an ILS, what is this called? Glide slope indicator. But you also have that if you go to select, and I think it's, is it HSI? No, there was some way to get it to work. I forgot how to do it. But there, one of these will give you this. I don't know how to get to it. Alright, what is this? Dock release. Okay, so when you want to undock, you press this button, or you pull it, rather. You just click it, and then you undock. This dock seal light comes on when you're docked so that you can't accidentally kill astronauts by undocking. This is the nose cone. We can open the nose cone now. Here we go. And look at that. The nose cone is opening, revealing the docking mechanism. This means it's opening, and it'll turn green when it's fully open. It's supposed to. There we go. So yeah, this is fully open and extended. So now we can dock up to a device, like a space station, like the International Space Station. Here's your wheel brakes, fairly explanatory. They slow you down when you land. Check this out. We're going to extend the nose cone ladder. And look at that. So now, how do you get into this thing? Well, there's your ladder. The next thing I'm going to do is open the outer door. So we go to open, and now this guy is opening, revealing the airlock. So, if you wanted to go outside on the moon, what you would do is you would open this, the inner door, climb into here, shut the inner door, depressurize, and when pressure is equal, you open the outer door, and then you walk out and climb down this ladder. So what's the last step? Open the inner door. And now we can see the inside of the craft itself, and the astronauts in it, and the bathroom, which is not occupied right now. Okay. So that's open. You saw the hatch already. The last thing I'm going to do is open the retro doors. And the retro doors will allow retro fires. These are bigger rockets than our translational ones. You can use these to slow down. Especially when you're getting close to the space station, you can use this. But not too close. That's when you use these generally. Generally what you do is you face the opposite direction of your direction of motion. Then you hit these until you get lower. Then you face the space station. And then you hit these, and then you come in the rest of the way with these. That's generally how it's done. Alright, here's mostly here's the most fun thing of all. Here's your propellant status. There are 2 types of fuels in 3 tanks. You've main, RCS, and Scram. Main and RCS use the same fuel. Scram uses its own fuel. This is the mass of the fuel that's loaded out right now, and this is the delta V that you can perform with said fuel. Delta V is everything when it comes to space travel. It is how much you can change your trajectory. Because when you're in space, you have nothing trying to slow you down. So you just roll. And you're held and swung via gravity. But you get to follow your own trajectory. Eventually, there will come a point where you need to change that trajectory. And it's going to require a delta V, which is in meters per second, in order to do that. Delta V generally represents about how far you can get, but that's not always true. Generally, the more delta V you have to expend, the more exciting the mission. So yeah, think of that as like your scorecard. This is the current flow in kilograms per second. Right now, all of the stuff's off, so nothing. We don't have any delta V capability from the scramjets because, hey, look, it's on, right? We're out of fuel, right? No, we're not out of fuel. What's going on is scramjets need air to compress, and there's no air. So without air, nothing's getting sucked out of the fuel tanks. So having the scram engines on really doesn't hurt anything. But you want to turn them off anyway, because once you start to move even the slightest bit, the fuel will start leaking, and it won't help until you need to be going about Mach 3 in order for the scramjets to really work. There is a way to do a fuel crossfeed. There should be a crossfeed switch somewhere here. These are relief valves. That's an airlock supply. You know, I actually don't remember where the heck this thing is. I could swear there was a way to crossfeed. Maybe you can't. Alright, this is driving me crazy. I'm going to see if we can crossfeed. Well, gosh dang it, you can't crossfeed. But you can in the Deltaglider 4, and you can in the XR2 Raven Star. Alright, I think there's only one more thing to show you guys before we start the next tutorial, which is going to be how to actually fly. And that is the rest of the craft. So I did turn around here. So if I do control left arrow, now I'm sitting in an astronaut seat, and now you can see the interior structure of the craft. So this is basically shaped like a pentagon. There's a trench in the middle that you can stand in. This, I believe, is a bathroom. This up here is the top hatch that opened earlier, as you can see. This ladder will fold down so that you can climb up. We got a window here that we can look out of. There's various, I guess, life support systems that aren't supported right now. And what is that? Chile or Mexico? I'm not good with flags. So I can't tell who that is. That's obviously US, and behind me is obviously China. I think you can customize this to be whatever you want. I sit, the pilot sits, basically on a platform above the airlock. It's a raised platform. Here's my controls. And if I down arrow, then you can see now here's the back of the craft. You can't quite see into the airlock, but that's basically the inner door of the inner doorway of the airlock. From here, you crawl into the airlock. I assume, you know, the airlock controls would be down here. So when you crawl through, actually, I think I can put the. Oh, that sucks. There's actually a minimum distance that you can set the camera to. That's kind of irritating. Yeah, you can see my feet there. So don't drop your coins, because if you drop something like your car keys or something down here, it'll slide off and then fall onto the floor 4 feet under where you're sitting. And there's no hope of getting that while you're flying. British vessel, by the way, in case you're curious. Alright, so I'm going to close real quick just talking about Delta V real quick. So typical Delta Vs. The problem with Delta V is it's perfect. It's nearly perfect outside of an atmosphere if you can calculate it. But because of atmospheric drag, it's not perfect. You have to factor in atmospheric drag, and that takes a lot of math. So Delta V is the difference in velocity between one trajectory and another. So right now I'm in a trajectory. I'm sitting on the Earth. Let's say I want to get into a low Earth orbit. That requires a delta V of 7,800 meters per second. But not so fast. The Earth has an atmosphere. You can tell it has an atmosphere because the sky is blue. If the sky were black, I would assume, and you could see stars behind it, I would assume that there is no atmosphere. That's good for the moon, not good for Earth. So, you're going to spend about 9,500 meters per second, maybe 10,000 if you're bad, 9,000 if you can manage to get your angle of attack really low. So just to achieve orbit, you're going to drop from 29,000 to about 20,000. The moon to land on the moon, you need about you need the 9,600 plus you need about 3, so that puts you up to about 12,600. Then you have to get into orbit around the moon, which puts you at about 13,600, and then you have to land, which puts you about 14,600. So you need about 15 kilometers per second, 15,000 meters per second. To get back to Earth, you only need about 2,000 meters per second if you do an aerobraking maneuver into the atmosphere, which can be dangerous. So the first time I recommend doing, and I'll do it on the tutorial, doing a manual braking. But when you get better, and when you begin to learn how the science of the atmosphere, you can do aerobraking and make this number even higher than it really is. To get to Mars, it's going to be 9,600 to get into orbit, and then it's going to be about 4 to escape, another 1 for V infinite. So now we're at 13,600, 14,600. Then you have to get into orbit and land on Mars, which is about 5. So we're at 19,600. I think they increased. I think the delta V used to be a lot lower. Holy cow. And you can land at Mars probably on about 17, because there's an atmosphere. Probably 17 kilometers per second you could land on Mars. Coming back, you'd need about 8. So, yeah, I guess this craft could go to Mars and back. If you want to swing by Pluto, you'd need about 12 plus the 9,600, or about 2,200. This is why I say this thing isn't realistic. You can get almost anywhere in the solar system in this craft. But you can't come back from there unless it's close to the Earth, like Mars or whatever. There are certain areas that will trap you. Venus will trap you. Jupiter will trap you. In fact, all the gas giants will trap you. Because there will come a point where the atmospheric pressure is at a lower pressure than your chamber pressure. So what happens is you turn your engines on, and the atmospheric pressure is actually higher than the pressure in your fuel chamber, and so you turn that valve on, and the flow goes back up into the tanks, which isn't good. So basically, yeah, no combustion happens, and you're stuck. So you have to be careful about that. But I mean, normally you wouldn't want to be going into a gas giant planet unless you're like me. You're just obsessed with them. But even so, if you want to do it realistically, it's really hard to do. It's really, really hard. But it can be done. You just need a big enough surface area. Okay, so that's it. Welcome to Orbiter 2016. I hope you guys enjoyed this first tutorial. The next time I'll actually drive this thing around. We'll fly in what's called a traffic pattern. And a traffic pattern...
Nose cone closed.
What? The nose cone is not closed. What is it telling me? Very strange. I think there's some... I don't think this development is completely finished, which is surprising given how low this craft is not complex. When you look at some of the things people have done, like Apollo, oh my God, the Apollo spreadsheets or checklists. Let me just say, you ingress at, I want to say 3 hours and 40 minutes before launch. And if I take the time to figure out where every single there's a cheat mode which will highlight the button you need to press. And if I don't turn that cheat mode on, I can't switch enough buttons in that hour to be ready for liftoff. Right? I can't, in 3 hours 40 minutes, I can't find and switch enough buttons for liftoff. So that gives you an idea. You could control up arrow, I think 3 times, control down arrow 4 times. It's ridiculous. But this is one of the most simplest crafts you can get. Let's look at something even simpler. The PB-01 shuttle. This tiny little thing. It doesn't have anything other than a glass cockpit. And get this. It has hover engines. I just turned them on for you. Uh-oh. Huh. Seems like the configuration's a bit jacked. Okay, we landed. There's not even a thruster down here. So, I mean, this thing's kind of cool, but, like, it doesn't... Let's just say that this guy... If you're looking to get in the air really fast, this thing works like an aircraft. This thing is probably your best bet for simplicity. This is the most simple craft. You can't do anything other than rotation and translation. I think you can dock. You can use the multifunctional displays in the HUD. That's it. Can't do anything else. But, I mean, if you're looking for a Star Wars-y kind of, you know, of maybe maybe not 10,000, maybe 2,000 years in the future, then this shuttle PB might be realistic. But at that point, you know, we're talking about no hover engines needed. We're talking about your wings. Your wings are like cartoon sized, and your life support system takes less area up than your body does. Which, I mean, I'm not ragging on it or anything. It's just, it's kind of. It kind of fits in more with the downloads that you can get for really advanced stuff, like Star Warsy, thousands if not millions of years in the future. But it's a fun little thing to drive around. There's documentation for it, and yeah, that's about it. So there's also one more cool craft you get. That's this planetary shuttle, which you can drive around. It has hover engines and such. So that's it for this first tutorial. We'll be flying around next time. Hope you guys enjoyed it. We'll be doing the next tutorial hopefully soon, and it will be how to fly a traffic pattern, taking off, flying around an airport, and landing like an aircraft. I'm going to make it very easy. I'm going to call off everything that we're doing so that you can follow me. Before, it was like, I'm going to turn to the left now, but I didn't tell you how to turn to the left. I will this time. I'm Dr. Aeronautics, and I will see you guys next time. Bye-bye.